What's up, gangsters? How about the promised episode 6 of this ridiculous rough inferior project? Yes, that is my new nickname for this thing because it is rough and inferior. But I still love it. The Brough Superior SS100 is, in my opinion, still one of the most beautiful things ever made by humans, and I want to build this thing for that reason. And this episode is going to get into a lot more specific problem solving that I hope will be, valuable in some way. Going to do some soldering, going to work with a 3D printed jig, and get this thing hopefully a little bit further down the track. Okay, so yeah, it's a couple of weeks later, and this all looks pretty much the same, like I haven't accomplished anything, but I've actually been steadily busy, like for an hour or two each day. So I mentioned that I was going to want to do some soldering. Well, I tested my favorite thing for soldering, which is solder paste, which is awesome because it's flux and solder in a paste, and you just put it, where you want it, and then hit it with a little bit of a flame from like a gas cigar lighter, and it works great. Until it doesn't. So this is good for brass, nickel, silver, stuff like that. Not so good for this variety of white metal. That was the effect right there. Turns out that this alloy of white metal, and if you don't know, white metal is an alloy of lead and tin and maybe bismuth and antimony, different things. And it can have a melting point range that's really broad, but that starts at about 100 degrees C. Well, this stuff, 137 degrees C, too hot. And it does not seem to mix either. So I've had to order some supplies, and I'll talk more about that when they arrive. So in the meantime, since I can't do any soldering, I have been doing an absolute shit ton of drilling and tapping. This thing, one of my issues with this kit is that the instructions are pretty terrible. I mean, there's not a lot that they can do about the quality of the castings, given that they are, this super soft white metal. It's about the softest alloy you can get. And they mold all this stuff in soft molds. So, they don't necessarily hold their shape perfectly. And, when it's done, the pieces are soft, and you're going to get stuff that gets bent, like the boss that you can see leaning to the left over there on the right-hand side. It is what it is. I mean, they could use a harder alloy of white metal, or they could go to Zamac, which is what die-cast cars are made out of, which is an alloy of zinc and magnesium, Zamac. It's a lot harder, but you got to have harder tooling, and that's a lot more expensive. And you only do that when you're going to be producing really high volume. So it kind of is what it is. But the instructions, yeah, they could do better, because you really have to look around to figure out what to do with all of these screws and holes. And it's not necessarily at all logically laid out. For example, that you're probably going to need to do something right here. There is, in fact, a little dimple molded in right there, and you can see that in the instructions, but they're not telling you what. So you have to go on a little bit of a trip and find where you can do that, or where you have to do that. Oh, it's right down here, and you got to follow the little arrows and learn that you need to drill and tap those for 1.4 millimeter screws, M1.4. Somebody in SMCG pointed out that you can just drill these holes at about the right size and then just screw the screws in. And yes, that is technically true, but I kind of view that as what you do if you're going to screw it together and never take it apart, because, you know, if it works, it might not unscrew very well. Anyway, that's not my favorite option, especially with machine screws, even though the material is soft enough. And so for me, if I want to have options and I'm not totally sure how it's going to go together, I need to be able to unscrew it. And that, you know, it's just as easy to just do it with a tap. Anyway, so that's that. This is actually not a bad example of where you need to do this. You know, having to map out the screw. This one's, here's another one. So you got to really look closely here and see, oh, there's an M. Oh, look, there's a screw there, but it's kind of hard to tell where it goes and what it does. Oh, goes through that thing, and it's going to be a minus screw, which if you look over here, you'll learn is an M1.2, and you have to kind of figure out, oh, you're going to drill and tap it into the back side of the primary chain cover. So, you know, it's like that through the whole thing. And to me, what made sense was to just go through and study it and figure out, you know, what I got to drill, where I got to drill it, and as you can see, put little check marks. And it has been pretty painstaking. My tapping arrangement got a little bit better. I made this little thing here, which is just nothing more than just a kind of a little holder, so that I can use my little miniature arbor press, and this thing just fits in the end of it that I had bored out for hole punches. And then I can position my tap using the little tapping handle and keep everything straight up and down. And it's relatively easy to turn, even for me being clumsy, and it's worked out pretty well. So anyway, got all that done. Well, not done. I still have more holes to drill and tap. But for the frame parts, I think I'm done, mostly. I have not chase drilled everything. Like you can see that again, even though these bosses are molded in, they're probably not deep enough. They need to be chase drilled. May not be big enough. I got to check those. The other thing is that I'm not totally sure that I want to keep all those bosses, because those are for the racks that you can hang the saddlebags on. And I'm not sure I'm even going to have the saddlebags. I'll talk more about that later. Anyway, if you're wondering what's happening here, this is a little fixture that I designed and printed using Fusion 360 and my Mars 4 Ultra to try and hold the parts of the swing arm correctly, so that when my solder shows up, because I had to come all the way from England, that things will be a little bit easier, because this is the piece that's got to go on there. And as you can see, the legs are spread way too wide, but it goes right here. And just from test fitting to get the square square protrusions to go into their square holes, because they didn't fit perfectly. Yeah, it was real. It was fussy. Anyway, so I made this little jig that I think will work. I used the rear axle all the way through that with the nuts, and at least there at the chain stays, they should be the correct distance apart and parallel and straight and all of that. But you can see that where I inserted that piece down there at the bottom, yeah, not good, not straight. And that's because I did not do a good job of getting the holes drilled for the M1.4s that are on each end of that in the middle of that piece right there. So what I'm probably going to end up doing is taking that out of there and drilling it out and getting the holes in the middle and just using some more of the same 1.4 millimeter brass tubing to pin that on there, just like I'm going to do here, and solder it in place. So yeah, that's kind of the deal with that. One thing you might notice if you're super sharp-eyed and have a good memory is that the surface of my little $20 Proxxon drill vise right here is different now. That's because the inside edges of the jaws right here were kind of round, because as you can see, this is a casting and all those edges are soft. Plus, these faces were not coplanar, so I just ran this down to my local machine shop guys and had them brush off this top surface and solve both of those problems at once. And now this is a much better little vise. Okay, so yeah, several days later and more progress, and really kind of a milestone. As you can see, I've got the basic structure of the swing arm built and at least temporarily attached to the frame. This thing, the swing arm was, it was a lot of work. Just to kind of walk through it, this is what one of these kits is like. So left and right side swing arm truss, this lower piece, you have to chase drill these holes. There was a piece sticking up here that I chose to clip off that I'll talk about in a minute that you have to chase drill. You got to chase drill these bosses because they're just not deep enough for the stubs of the pieces that plug into them, which is what you've got right there on the end of that thing right there. You can drill those out 1 millimeter or 0.9 actually gives you a really nice fit. Anyway, so you got to do that. Same thing with that one in there for the chain stays. Then you've got drill and tap 1.4 millimeter there. Drill and tap 1.2 millimeter there. Clearance drill 1.4 millimeter in those two spots. Then you got to clean up all of the molding lines, and this is a pretty good place to see those. So it's minimal, but it shows a lot. That witness line runs around every single one of these parts. And this is just, look, honestly, it is just more difficult than if this were a styrene kit. Because not only are these things just difficult to hold on to while you're doing all that cleanup work, but because it's soft enough that you can bend it pretty easily, but it's not so soft that it's easy to just clean all that off. You can scrape it off a bit with a blade, you can sand it off, you can file it off, but one of the things that I've been using a lot for cleanup is my Proxxon and my selection of dental burrs. This one in particular works really well. It's a little tiny carbide burr, and it'll get into a lot of pretty tight places. And I spin it really fast, like 15,000 RPM. Hit it with my little foot switch, if I can find it, down there on the floor, and it works great for doing cleanup work. If I, sorry, bumping the camera as usual, of course. If I need to get a little bit more serious, I have some other burrs in this collection. that I can use, you know, just depending on what the situation is. But I got these for free from my dentist. All I had to do was get like an $1,800 root canal or something like that. Maybe it was a crown, I don't know. But he gave me a whole bunch of these for free, and I've had them for years, and they are wonderful. Okay, so now, as I mentioned before, in order to be able to get this done, I needed to get some supplies, some solder. Because even though it doesn't really tell you in the instructions that you need to, I wanted this structure to be as strong as possible. And so right in here where the upper part of the swing arm plugs into those square holes, I intended to solder that, and you can see that I did. Same thing down here at the bottom where this this cross member is, down here at the bottom. It has screws in the ends, but I wanted to make sure it was really good and strong. So once I had it, you know, attached with the screws and was happy that everything was straight, I went ahead and soldered those. Then once I got it to the point where I was ready to put this top piece on, you can put this top piece on here without the whole swing arm being attached to the main frame, but there's a lot of slop in these. You could totally screw up if you did that and ended up having to bend it or do something crazy if you didn't get this in the right orientation. So I wanted to temporarily attach this part of the 4-bar linkage and then go ahead and solder this pivot joint here, which really, theoretically, I think is really supposed to be able to pivot to help you get everything correct if you do all this first. But I wanted it solid for a couple of reasons. And then one thing that they don't really show you is that in the instructions very well is that underneath here there's a couple of tabs on the bottom of the of that swing arm piece that plug into this cross piece right here, and that makes things a lot sturdier. I'll show if I can show you here in the instructions where that is. Right here, these little L-shaped things right here, the bottom of the L, this tab right here, plugs into slots on the back side of part number M37. And that helps keep everything constrained and located. And I chose to solder that as well. So one thing you'll notice is that right here, it calls for these M1.2 screws and these photo etch pieces. So this is one of the places where I had to make a decision about what version of this thing that I wanted to build. When you look at pictures of these broughs, it's really kind of hard to tell because they all, honestly, from a distance at least, sort of look the same. But there are differences. And I had commented, I think, in one of my earlier videos that I wanted to build this as one of T.E. Lawrence's broughs. And I failed to even notice that actually that's the way they've got it configured. CW2275 is actually the one he was killed on. This was his, I think his 7th brough superior. He never took delivery of the last one. But, so this is about a 1934 SS100, I think. Anyway, it's in the Imperial War Museum in the UK, and there's actually not a lot of great photos of it that I could find. But one that you can see is that it's got these chrome flat pieces on top of this part of the linkage. Now, I decided that I was not going to build this one for a couple of reasons. One of which is that I found this one listed on an auction site, which has an absolutely wonderful set of reference photos. There's like 50 photos from every angle, and it's just beautiful. And I love the lines of the rear fender without the passenger pad and all of the bag racks that they want you to add in this step. So I'm eliminating this front one and the pad and those chrome pieces that you would install right there. And so that had a couple of implications. One of which was that I was not going to use the slotted head screws right here at this pivot. And so what I decided to do was just put a pin in there to represent the bolt. And that's just a bit of 0.9 millimeter nickel silver rod. And then I'm going to 3D print a nut to go over that I'll put on after I paint everything black, because the nut and the bolt are actually natural metal. So I'll just take the black paint off the tip of that with lacquer thinner and put a little 3D printed nut on there that's painted silver. So anyway, there's that. So as far as those bag racks go, so that's what all of these bosses here were for. And I, because I'm not going to include that front one, that front rack part, I took off the boss that was on the front, sticking out going this way on both sides. And I just did that with my little Proxxon rotary tool. So anyway, that's all that, and that's why it looks the way it does. Now, I've mentioned several times the soldering supplies, and if I can find everything in the wreckage of my workbench here, okay? So these are the materials that are recommended. Took about, I don't know, about 10 days to get here from the UK. But these are the soldering sticks. It doesn't come as a wire solder, coil like you're used to. It's these sticks, all right? And I think the reason that you can't get this in the United States is because it's got lead in it. But the important part is very, very low melt, 73 degrees Celsius. So you gotta have that, and you've gotta have this flux, and the combination of the two, with it shipped all the way over from the UK, was about 25 bucks. Really wasn't bad at all. And I'm going to demonstrate, but this stuff is pretty cool. Like, it's magic. I tested it out a couple of times, and the results are pretty good and pretty easy to achieve, with some caveats. So let me do a demonstration. I mentioned that there was a piece that I decided to eliminate right here, and that is this little tab that I just clipped off of there. You can see it in the instructions right there. Where it says to put that M106 bolt head right side only. You can see where I got the check mark, and it doesn't appear to be for anything in the kit. I can see it in a few pictures of different broughs, but again, there's no indication of what it's actually for. And on this one that I've chosen as kind of my example, it's not on there at all. So yeah, just decided to clip it off. Okay, so let's do a little quick demo. But before I start that, let me just issue the disclaimer, which is I am no kind of soldering expert to begin with, and this is my first experience with soldering white metal at all, and doing it on a Model Factory Hero kit. So look, this is just me passing on what I've learned, not saying it's necessarily the right thing. So the first thing I'm going to do is clean this tip. I do know from my limited soldering experience that a very clean tip is normally what you want. Now, along with this Hako, however you say it, soldering iron, I bought this stand, and it's got this brass sort of Brillo pad looking steel wool thing in it, which is nice. You can also use a wet sponge, but this is cool because, oops, well, yeah, don't do that because it'll fall apart. Anyway, this is cool because it alleviates you having to have some water around for your sponge. Now, having the thing perfectly clean, however, is not necessarily the best in this case, and I'll explain in a minute. But first, let's talk about temperature. So the YouTube guy that did the video on soldering white metal kits, Model Factory Hero in particular, had his iron set at 550 Fahrenheit, so I did the exact same thing. For those of you who don't work in Freedom units, Siri, how much is 550 Fahrenheit in Celsius? Siri, how much is 550 Fahrenheit in Celsius?
The answer is 287.78 degrees Celsius.
Guess she was taking a nap or something. Anyway, so yeah, about 280 C. Now, I have seen other people talk about doing it at like 200 C, and the melting point of this white metal is right around 100, and the melting point of the solder is only 70. So I'm sure a lower temperature would work, but again, I'm just going with what the YouTube dude said. And so here's how it works. What I'm going to do is put a little solder around this brass pin right here in preparation for adding the lower frame cradle. So just going to use a little brush, and it's good to use just a brush like this as opposed to the brush that's in the solder, because you don't want the brush that's in the flux, sorry, because the brush that's in the flux will give you way more than you need, and it'll be all over the place, and that might be a bad thing. Okay, so first thing is to get some solder on the tip of the iron. Now, as you can see, that's how low the temperature is. Like, I just dribbled some on the workbench and didn't catch on fire. No big deal. You can also see that it is difficult to get the tip to 10. My limited experience with traditional soldering is that you want to cover the tip of the iron with solder, but it doesn't work with this stuff. And I don't know if it's because it's lead, it's got lead in it, or if it's such low temperature or what. But this is like, putting water on a windshield that's got Rain-X on it. It just kind of beads up. That actually is probably the most I've ever gotten to stick to the tip. And it's actually way more than I need for this tiny little operation. Because now that I've got some on there, I'm just going to go over here, touch it to the workpiece, and there we go. The flux should draw it into the workpiece, kind of like extra thin, or come on, focus. Kind of like extra thin, or extra thin super glue. I don't want to touch it. I'm afraid it's going to be hot. Come on, are you kidding me right now? All right, we'll just try it this way. So there you can see what's going on. So that brass pin is well and truly stuck in there. There's actually a little bit more solder around that than I want, because I need the tip of that frame member to be flat, but I'll just smooth that down. Not a big deal. So that's basically it. Now, here's another sort of thing that you can do with this that is pretty good. So you can see that right here, I got a divot right there by my finger where my rotary tool got away from me. All right, so once again, going to get some solder on the tip of the iron. And again, I don't need a lot. And of course, watch, now that I don't need a lot, or I need more, I won't get as much on here. Okay, and then I'm going to just, if I can do it, and deal with the camera at the same time. Sorry for bumping into it. Okay, that didn't go very well. Okay, I got a little bit more solder on here. Of course, this never works when you're going to demonstrate it live, right? But there we go. That's what I was trying to do, is just sort of put down a little bead of solder to fill in that scar, and maybe pile up even more on top of it so that I can file it down, just kind of like, you know, filler putty. I mean, even if you get way more than you need like that, it's pretty easy to file it down and smooth it off. So there we go, just like that. What I was going to say about the tip of the iron being clean is that one thing that I've kind of discovered is that it seems to be a little bit easier to get enough solder on the tip of the iron if it's not perfectly clean, or if it's a little bit contaminated. Like, see right there, it just doesn't want to go on there. So what I've been doing is touching it to the workpiece, a piece of this material, and then doing it. And see, that's helping a little bit, not a lot, but it's just kind of, you know, it's one of those things. It can be a little bit frustrating, but you just kind of have to work with it until you can get enough on there to do whatever you need to do. And, you know, you may waste a lot and you may have to go back multiple times, but it's kind of how it seems to go. I don't, you know, if anybody knows the answer to that, comment below. And the adventure continues. As I was saying earlier, I have soldered the lower frame section to the main frame section. And as I mentioned, yes, that frame cradle is just not long enough. So my plan is to chop it off here and put some tubing in there and stretch it out. But before I can do that, take a look at this. So yeah, look at the frame. Yeah, you should be able to see pretty easily there that we have a problem. The back part of the frame and the bottom part of the frame are going a different direction than the rest of the frame. So yeah, gonna have to try and just do a little bit of brute force correction there. Okay, so a little pushing here and a little twisting there, and that looks better. Okay, so this is done, and I actually feel pretty good about it. I was going to show it with just the pins in it, and I forgot, but basically I just drilled holes as close to the middle of each of those frame members there as I could, and a 1.1, 1.2 millimeter hole, and used some 1 millimeter nickel silver rod and put it together. Put the screw in it to hold it down, but it still was off center. So once I had these soldered, and what I did was I just basically put a lot of flux in there and then held the solder and the iron right above it and just dripped a bit in there until it kind of naturally filled itself in. And now I have plenty of material to be able to file that down to where it hopefully won't even show. Then I went back and took the screw out, drilled this back out to like 1.5 millimeters, put a piece of brass tubing in there, got it centered up and soldered it, and did the same thing, just dropped some in there. So yeah, it's all square now, and or squared away, at least that far. And so now I can take the engine cases out and get on with the rest of the work on this main frame. I had left the engine cases in because I wanted to make sure that this down tube was in the proper place, you know, relative to the rest of the frame, because it's pretty easy for it to get moved or bent. And there's just not a lot of slack. If I, try to take up that 2 millimeter error down here by adjusting the holes or whatever in the engine cases, that would have gotten ugly. I didn't want to do that. This was the right way to do it. So anyway, that's done. I'm gonna get these engine cases out of here, get on with things. As you can see, I've also already soldered in this upper spring mount, spring brace, whatever it is. It's where the two suspension springs that come up from the swing arm right here contact the main frame. So that's much more solid than it would be if it were just glued in there. So anyway, I'm going to get the rest of the work done, including getting the holes drilled and tapped for the front end and whatever else needs to be done. And then I'll be able to go back and permanently attach the swing arm to the back end, and hopefully at that point not have too much more work to do before this thing is ready for some paint. Okay, so there you go. Hopefully that was somehow useful, even if you're not building one of these things. And I can't imagine why anybody would want to watch these videos if they weren't building one, but yeah, you never know. Anyway, between the end of this clip and this state of progress, a lot of things happened that I frankly did not capture on video in real time because I was just a little beat down and a lot tired of it. So what I'm going to do for the next episode is just summarize all of the things that I did to get it to its current condition, and then we'll go from there. So yeah, as always, if you've suffered through it this far, I really appreciate it, and much love.